Hello there, and welcome to this second video in this, I think probably about 15-part series of making this MIDI CNC router. In this episode I'm utilizing two machines at once here. I'm using the CNC mill to mill out the recesses for these threaded inserts. Now, what you see me doing now is I'm just deburring the edge after cutting them all off, and I'm taking off some of the well, actually rust that was on the outside of this bar, because it was the only piece I had about the right size, and of course it's been around in my workshop for a couple of years, I think. But a little bit of fine sandpaper, I think it's actually emery paper, and a file would bring it up looking like a new pin. Of course, you've got to be very careful doing this sort of thing in a lathe. Now make sure you haven't got any loose clothing, so it could get caught up in the lathe chuck there. And you can see it fetches it up like new. And of course, each time I manage to clean one of those inserts up, the little CNC mill is just about ready to be swapped over to another position on the material to either do the underside or the other end. Can get a little messy doing this job because of course I'm running flood coolant. And I'm lining the material up with the back corner of the vice jaw. If I can, I can get it there within a few thousandths of an inch by eye, and everything turns out square and perfect. Mill RPM is around 4,000 RPM, and I'm running 20 millimeters per second of cut speed. And of course that's a 6 millimeter 2-flute end mill. It's a fairly new one too. So we have our mold steel pieces all cut off and deburred and cleaned up a bit. So now I've got the vise set up on my trusty old manual mill. Now I've had this thing for about 25 years, and it's never failed. So you can still buy them. They're sold, well, in Australia it's here in Forbes, but in the States and in England, I think, Grizzly, Harbour Freight, they sell this model, so you can still actually buy this model, but don't buy the one with the round tubular column. This is a square column with dovetails. It's much more stable and rigid, and they're an excellent machine to convert to a CNC milling machine. And maybe after I've done these two projects, making these two CNC routers, I think I might convert this one to a CNC mill, because it would have the same work envelope as the Tormac 1100 and damn sight cheaper. Okay, but at the moment it's manual, so I've just fetched the table over so it's roughly in line. We don't need to be too exact here. Okay, it is really just putting a threaded insert, as it were, into those aluminium stretchers or chassis members. So it gives you something solid to actually screw into. Okay, so we'll take him that way a little bit, and then we'll take this down. Okay, so all I'm doing is I'm just going to take about, put a 3mm flat on there, which gives me something really, I'm only doing it on one side, it gives a real sort of positive area to be able to drill a hole straight through it, because you try drilling on a rounded surface, the drill will wander all over the place, even if you use a center drill. So this is the best method I've found anyway. And you can do all this by eye. Well, I can anyway. I'm just going to take about a 1/16 of an inch off the top, and I'm just going to move it through that way. So lock this up so it's not going to judder or move up or down on the sort of geared part. And WD-40 coolant, cutting agent. I use this on everything. Works brilliant on aluminium and, well, mild steel as well. So I'll just fit you in for a bit of a closer look, and we'll make flat on this. I've just changed the cutter because that last cutter was a little bit blunt, I think. I didn't want to go through very well. But this is how a cutter should go through steel. Like that. What I'll do is I'll put the next one in, bring the cutter through the opposite direction so you can see it actually cutting. Perfect. Okay, this time I've swapped the mill out. I'm probably going to have some people write in the comment section too that this isn't strictly the right chuck to put a milling tool in and do a sideways milling action, and they'd be absolutely right. But for the small amount of milling that I was doing, this is a big heavy duty chuck, and it's quite capable of hanging onto a mill and cut sideways for small jobs like this. So we'll just put that right. So in here now I've got a center drill. Well, I'm just going to mark all of them, just put a center mark in there so the 7mm drill that I'm going to drill it through with doesn't wander off. So here we go. I've speeded the, I'm going to maximum RPM, 1600 RPM now. So here we go. Bit of a start. Now it's fairly easy for me to find this flat again, and because I have the edge of this, the material, up against the edge of the jaw there, I'm reasonably certain I can put this within a couple of thousandths of an inch of, you know, the same position. So I'm going to do that with all of them now, and then we'll swap into the drill and we'll drill them through. So there's the center mark or center drilled piece. Okay, so I'll do it to all of them now, and then we'll swap the drill over and drill them through. Okay, so we've got a 7mm drill in there. We've got to change speed because that's a little bit fast. That was 1600 RPM. I'm going to knock it back to about just under 1000 RPM, so that's the medium. This is like an old-fashioned truck gearbox. It's like, you know, it's got no synchro mesh or anything like that, so it's just like a straight cut teeth box. And so you have to have it stopped to change gear. So here we go. Chips are coming off nice. Is that. Oh, that's a bit warm. So now it's down to the slow, laborious job of tapping a thread into each and every one of these. If this was aluminium, what I normally do would be stick the tap into my cordless drill on low speed and just tap the thread with that. Steel, different story, can't do it. You probably end up busting the end of the tap off. So, a little bit of WD-40. 1.5 turns in, half a turn off, out. What that's doing is, if I get a big one I can show you. Okay, so if you notice the tap has got 3 areas and like a threaded area which is the teeth. So what happens when you turn it like this in 1.5 turns, it the material that's cut off by these teeth curls up and collects inside these fluted areas. And when you turn it back half a turn, you snap them off and they fall out. If you didn't do that and kept on going and going and going, what would happen? They would jam up in here and jam the tap up in the hole, and there again could end up busting the tap off. I mean, these are HSS steel. They're very, very good hard steel, well made. But if you abuse them, you know, or over twist them, they'll snap off like a carrot. On a cold day, on a icy cold day, if you drop one of these on the floor, it's possible to actually crack it straight through. But using it as to actually machine with, to cut a thread, it's very good. It'll stay sharp a long time. So it's good at sort of an abrasive type wearing, but shock doesn't stand up to it at all. Okay, so, and you can sort of feel when it comes to the thread, oh, stops dead there. Half a turn, third half, back just over half a turn. And you do that all the way through. I don't know whether you notice the stuff. I'll zoom you in actually in a minute. And you can see your stuff falling at the bottom. Okay, up to the thread, half a turn, half a turn, half a turn, back half a turn. You can see the swarf falling out underneath. It's gone nearly all the way through now. This is a tapered one that I'm using, a tapered tap. You're going to take it nearly all the way through like that to make a good 100% thread all the way through. Take him out. Clean him up a bit. So you'll notice there's the thread up here is quite, it's quite, not much of it there. There's no peaks on it. As you go further in, you see the peaks get higher of the thread. So this is like a start. It's a tapered start, and it makes it easier for you to go into the material and cut the thread. So this is a number 2, second tapered tap. There's normally 3 in a set. There's one that's got that's more tapered than this one, which is the middle one, and then one which is called a plug tap that has no tapered part of the thread at all. So you'd sort of, if it was a blind hole, in other words, a hole with no hole all the way through, and you wanted to cut a thread in it, you'd use this one first and go all the way in, and then you'd use a plug tap, which is similar to, let me see, have I got one here? I haven't got a plug tap, I don't think. Well, that's a better example of a plug tap, I suppose. See, it's only a couple right at the very front there, and then the rest is all full thread cutting. So you'd use that one then to sort of go all the way down right into the bottom. So that's really how to tap a thread. And there's the result. Nice clean thread. And these are the bolts that we're going to be using. Hopefully it's the right thread. Yeah, look at that. Beautiful. Okay. I suppose I better show you how this works. So we've machined these, cut them off to length off a bar, machined this parallel hole through, and we've made these. Well, this one goes into here like so, through into that one, fairly tight fit. There you go. So you have one on each end, and this lies flat like this, and I'm going to have two y-axes, one that runs down here, the other one runs down here, a bolt going through up onto here. Okay, so it's a chassis spreader, and there's 5 of these over an area of 600 millimeters, which is, what's that, 2 foot. So it's going to be held very rigid. I'll probably have another one further up the back, because these the both XY side rails then that the axes rails are on, and the bull screws are on, which then the gantry runs off. They're 160 millimeters high. So, you know, that's why I've got these. They're very, you know, quite solid aluminium, and I'm not using, although this is extruded aluminium, right, it's got a 3mm wall, it's not under any great load, you understand. It's just there to, as a chassis member, to hold the y-axes left and right upright and together, and brace it all up, and it's going to be more than man enough to do the job. For a CNC router of this caliber, I am not a great lover of welded steel chassis, because as soon as you weld them, they pull all out of shape, and it's difficult to, you know, get them absolutely square. Well, this method, I can keep everything very square and very solid as it would need to be. So, I suppose the next job now is to cut the material to assemble the left and right y-axes, and I'll actually cut the x-axis assembly as well, because they're all identical. You remember me saying right at the very beginning of the last video that I was going to make it modular? Well, that's the easiest way to do it, because then you're only designing and making, you know, sort of one assembly that's going to do 3 jobs. You know, left and right of the y-axis and the x-axis. The only different one is going to be the z-axis. The only difference with that is it's just half the length, or just under half the length actually. So okay, so we'll leave this video here, and I'll put it together and publish it for the weekend. So this is, I suppose, really video number 1. The first parts of the MIDI CNC router. I hope you enjoy the series, and please subscribe, press like, and incidentally all the information, all the measurements, drawings will eventually be on Patron. So if you want them, you go along to my Patron pages and you'll be able to download from there. So thank you for joining me, and it's bye for now.